Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the infamous Therac-25, a medical device whose failures led to tragic consequences. We'll be exploring a hands-on assignment from MIT's 6.033 course, focusing on the software and concurrency issues that caused those failures. Exciting, right?
Absolutely. The Therac-25 is a classic case study in software safety. I'm particularly interested in how a seemingly simple interface could lead to such catastrophic errors. So, let's get started.
Right. The assignment starts with familiarizing ourselves with the Therac-25's operator interface. It's a text-based interface, showing parameters like beam type, energy, and treatment time. Imagine a screen full of numbers, and the potential for errors is immediately apparent.
Exactly. The interface itself seems quite simple, but the underlying software is where things get complicated. The assignment highlights the importance of understanding the interaction between hardware and software, especially in safety-critical systems.
The assignment then moves on to the crucial part, reproducing the malfunction 54 error. This error, as we know, resulted in massive overdoses of radiation. Question 1 asks, what's the sequence of events to trigger it?
That's the million-dollar question. The paper details a race condition in the software. Essentially, if the operator entered data quickly enough, a crucial safety check could be bypassed, leading to the malfunction.
I see. Interesting. The second question asks how difficult it is to trigger this condition. The assignment provides a simulator, allowing students to experiment and see firsthand how easily the error can occur.
And that's a brilliant pedagogical approach. Hands-on experience is invaluable in understanding these kinds of subtle, yet deadly, concurrency issues. It makes the abstract concepts concrete.
Precisely. The third question asks students to use the simulator to trigger malfunction 54. It's a practical exercise to test their understanding of the sequence of events. It's a bit chilling, isn't it?
Absolutely chilling. The assignment then takes a dramatic turn. Part B involves using an actual, unmodified Therac-25 in a controlled setting at MIT's TEEL lab. Can you imagine?
Yeah, that's intense. It's a unique opportunity, but also a serious responsibility. They emphasize working with a partner and following strict instructions. Question 4, rather darkly, asks how much radiation the students received.
That's a sobering reminder of the real-world consequences of software failures. The whole assignment is a powerful lesson in the importance of rigorous software engineering, especially in systems where human lives are at stake.
Exactly. It's a compelling case study that highlights the need for thorough testing, robust error handling, and a deep understanding of concurrency. This isn't just an academic exercise. It's a stark reminder of the real-world impact of software.
Absolutely. Thanks for walking us through this fascinating and somewhat terrifying assignment.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for more insightful discussions. Goodbye.
Bye-bye.